isn't targeted at just small exchanges where you might have 1, 2, 3, sort of a startup exchange with just a handful of switches. It will scale to a full medium, large-sized IX. And besides INX, we have people like LUNAP and INXZA, all large exchanges that rely on IXP Manager. So what is IXP Manager? For anyone who doesn't know, it is a full stack management system for IXPs. What we like to say is it teaches and implements best practice. So it, the knowledge of myself and Nick Hilliard and the rest of us at INX who have been developing IXP Manager and running exchanges for years, has all of that has been distilled into IXP Manager. It's in use by at least 166 IXPs. That's 166 IXPs that we are aware of, which back of the envelope calculation is probably more than a third of active exchanges around the world. I think one of the most important things about IXP Manager is that it's free and open source software. And then there's loads of resources on its webpage, ixpmanager.org. Let me just flick over to that for 1 second. So this is ixpmanager.org, our website. You can see we keep a count on the number of exchanges that use it. On the website, you're going to find lots of information about IXP Manager, history, and so forth. If you want to, one of the things that people often look for is how to install it, and we've got install out here front and center so that you can find that really easily. And then we have a number of videos and tutorials explaining how to install IXP Manager. One of our most important parts of the website is the community page, where we try and keep track of all the exchanges that use IXP Manager. And in fact, if you're an exchange that uses IXP Manager and isn't on our list, please come and just submit your IXP and we'll add you to the map and we'll add you to the list. One of the other things our community page does is it keeps track of some statistics. So you can see that over 7,000 networks are connected to exchanges that use IXP Manager, representing 111 terabits of connected capacity and representing nearly 10,000 connected ports. So that's quite a lot. This is very much an under count. Right down the bottom, we explain the methodology. And of the 166, we're getting good data from 98. The rest is from PeeringDB, which, because networks have to assert that they peer at your exchange, that's going to be very much undercounted. And then the other thing I want to show you here is just a support section. We have extensive documentation. I'll flick onto that later. One of the things about our main method of support is community-based, and it's through the mailing lists. So if you have a question about IXP Manager, head over to the mailing lists, subscribe up to them, read the best way to ask for help, because the better your question, the better quality answers you will get. We were very much about support out in the open. So even if you email any of us privately with a very much technical or how-to question IXP Manager, we're going to direct you to the mailing lists. On this, you're going to find an archive of all the talks, workshops, presentations we've done over the years. It goes right back to 2010. So if you want to get sort of a drill down, a detailed view on a particular feature of IXP Manager, come here and see if there's a talk on it. And then the last one here is tutorials. So last year we started compiling videos of how to install your first steps, how to upgrade, how to manage members and connections and so forth. And we're going to build onto this as well. In fact, for the work I've done for putting this webinar together, I'll probably break that into 2 or 3 talks on root servers for the website as well. So that's IXP Manager's website. The development effort for IXP Manager is twofold. The first one is, as at INX, we continue to develop to solve our own problems. But the great thing about that is whatever problems as an exchange that INX has, and at this stage we're sort of a upper middle-sized exchange. Whatever problems we encounter are typically going to be problems that other exchanges have as well. We provide the core team, the project management, development, oversight. And I think anyone who's involved in open source software knows it's a vocation. I mean, it's, we've got INX time on it, we've got some Island Bridge Networks time on it, we've got some personal time on it. There's often evenings and weekends we'll be on mailing lists and doing code checks and writing code and stuff like that as well. And we're also usually the first user in the sort of development open source parlance. We eat our own dog food. So usually when we develop new features, and by the time they get released on GitHub and officially packaged, we've been using them in production at INEX for some time. The other development effort is that we have a full-time developer called Jan Robin, and that's thanks to our patrons, of which APNIC is one, which we're very grateful. And our patrons are sort of, they're not IXPs. They're people who are sponsoring for the good of the internet, or maybe they have a vested interest, like for example, AWS and Facebook. They would peer at exchanges that use IXP Manager, and they would like to see the project succeed. We also have sponsors, and sponsors are typically exchanges, IXPs that use IXP Manager that want to give back to the project. Sorry, just hit the cough button there for a second. I'm not going to go into too much detail on the top level objects in IXP Manager. And what we'll see now in a minute when we click into IXP Manager, we'll get a good view for how it looks. But the things that you would expect to be in there are in there. Your facilities, where your IXP has a POP, racks that are in that POP that belong to your IX, infrastructure. So think of infrastructures as an IXP. So at INEX, we've got 3 infrastructures defined in IXP Manager. VLANs are obviously an element of an infrastructure. Then switches belong in an infrastructure and a rack, and switch ports belong in a switch. So the kind of things that you would expect. One thing I do want to mention, because we're going to see a bit of this as we get into the root server stuff, is interfaces in IXP Manager. The one thing about IXP Manager is that the schema that was originally created 20 years ago, nearly 20 years ago, has pretty much survived to this date. And rather than going through the texture, let me give you a diagram of what how we represent interfaces in IXP Manager. And these are kind of these are how members connect to the exchange. So we have a database object that we call a virtual interface, and that's this big box in the middle. And a virtual interface has one or more physical interfaces. A physical interface is just sort of, syntactic glue within the database. And a physical interface has a one-to-one relationship, as you might expect, with a switch port. And a switch contains one or more switch ports. So essentially, you can see here from a virtual interface, if you have a single interface, it's just a normal port. If you've got more than one interface, you're going to be in a lag, aggregated group of ports. A customer will obviously own a virtual interface. And the other big object that we'll probably see much more of is a VLAN interface. And the VLAN interface really defines the layer 3 configuration for your customer, your member. So what VLANs they are peering on, their IP addresses, and so forth, whether they're whether they should be a part of the root server, AS112, and so on. So the kind of key information around the layer 3 connectivity element of it. So we're going to do a quick demo now. We're going to go into IXP Manager. And for the purposes of this, I have created a dedicated instance for this APNIC. That's why when you're looking at the graphs here, you're just going to see these dummy graphs, because I don't have a real switch or anything. So it's just filler to show you where the graphs would ordinarily be. This is the view of IXP Manager as an admin when you log in. And you can see in your IXP admin action, we've got these top level objects I was talking about, the facilities, the infrastructures, switches, VLANs, and so on. In IXP Manager, we've kind of an easy drop down here to look at what members or customers have been configured. When you install IXP Manager, the first thing you will do is you will create a customer object for your own exchange, and that's why APNIC IX exists there. It's just a pretend exchange for this demo. I've already added 2 customers, so I'm going to add a third customer or member now. And when we go to create a new member, you can fill in all these details manually, but what we have is a very handy little thing here, where if you put in an AS number, I'm just going to pick a small network, sort of a regional eyeball network in Ireland. And you click populate. What IXP Manager will do is it will go off and talk to Peering DB, and it will get whatever information is publicly available. If you've configured IXP Manager with your Peering DB credentials or a set of Peering DB credentials, it will log in and it will be able to get better information. For example, it might be able to pull out the peering and not email addresses. The other just thing I want to show you here are two things actually that are important in IXP Manager. The first thing is on an awful lot of pages in IXP Manager, in fact, most pages, on the top right, you're going to see a documentation button. If you click on that, it will bring you to the documentation, docs.ixpmanager.org, and it will bring you to the relevant page to do with the page where you clicked. So for example, here I'm adding and editing members. So this brings me to the page about editing and managing your members. And one of the things we see here straight away is that we have a video tutorial. So anytime we create a video tutorial, we'll put that in the documentation so you know straight away that if you don't want to go and read all of this text, there is a tutorial where we go through it. And then we get all the details about adding customers and what all the different fields mean. So there's a full set of documentation there to try and help you along. The other thing to notice is that most pages have this help button. If you hit help, you're going to see this huge amount of text pop out, and this text will try and explain what we're looking for in each box. I'm just going to hide it off there again. So let me just finish adding this network. As I said, what we're looking for in some of these are in that help box. Okay, so IRRDB source is for the root service, and we'll see later. If we're going to be doing filtering, is where we should get the prefixes, and in this case, it's going to be right. You can see when we drop this down, IXP Manager comes pre-provisioned with a huge amount of IRRDB sources out of the box, but you can edit those and add more, and you can create, sets of them as well within the UI under. It should be under. Here we go, IRRDB configuration. But as I say, out of the box, we come with most of the ones you're going to need pre-configured. I think the only other bits of information I have to add here is knock. Okay, so that's a member created. It's looking for some registration and billing details. IXP Manager, by the way, doesn't do any kind of billing functionality, certainly not at the moment. What this is really to allow members to change their billing details so that whoever in your IX organization looks after billing can make sure that information stays updated. Okay, so this is our member overview now. You can see just customer overview. So, it'll tell you lots of information about the member and things such as ORS client and things like that. What are the root server clients? So one of the things I want to do here is give them an interface, a connection to the exchange. And I can do that by just clicking provision new port. And this brings us into a wizard. So I have to pick a VLAN, and I'm going to pick peering LAN 01. And again, this isn't a tutorial in IXP Manager. There's all of that documentation and videos are there. And all of this, what we're doing here, for example, will be covered in, first steps setting up IXP Manager, about creating your VLANs and your IP addresses and everything else. This tutorial is about the root servers, and I want to sort of move to the meat of that. So I've already created my VLANs. This member will have V4 and V6. I'm going to give them port 3 on this fake switch that I've added in earlier on. Their port state is going to be connected. There's a few things there. For example, you see quarantine, and that allows you to provision quarantine root collector sessions and configure the port in a quarantine VLAN away from the rest of your members when you're first bringing someone online, for example. The max BGP prefixes, that's your BGP prefix limit. When we pull from PeeringDB earlier on, we take whatever member has set in PeeringDB, and I think we add about 20%. I think I spotted for this member came up with 6 or something, and it will take what's in the customer's definition, unless there's a higher one set on the interface itself. So I'm just going to set that to 20. 20 or 50 are normally good values. I'm not going to make this a root server client just yet. I don't want to have any clients just for now. We'll show you those shortly. 34. I'm just going to pick these IP addresses. See, I've set up some clients, and we'll talk about my demo system shortly. I just want to. I think one thing I forgot when I was doing this is that I actually set an MD5. So I just want to get the right MD5 so that this will be able to connect later. Here we go. That's all I was looking for. Okay. Here it goes down. Okay, great. So that's our virtual interface created. And particularly if we go and look at the member overview now, you'll see on ports. So here's our connection 1, switch 1, port 3. You can see our IP address details. We can see that they're not a root server client. We can see their MD5. And we can edit this. This is the virtual interface that I was talking about earlier on. The virtual interface defines things like whether there should be a link aggregation, MTU, some sort of top level information. Then we have our physical interfaces. You can see we can add another one to create a lag, for example. And we've got our VLAN interfaces. So you can see those elements that I was showing you in the schema diagram earlier on. Okay. Now that I've added a member with an interface in IXP Manager, just to give you an indication of what IXP Manager can do for you. Now that member exists, a load of stuff can be auto-provisioned from IXP Manager. A root collector is different to a root server. A root collector we use at INX to, any member of INX has to peer with the root collector. They have to advertise their roots to it, but a root collector doesn't advertise any roots to the member. So it's export none, and it doesn't share roots with any other system. So it's a closed system, but it's used for diagnostic purposes, for monitoring purposes. And just the same way that we can create root server configurations, which we'll see shortly, we can also create root server or root collector configurations. All of the graphing will be auto-configured. So it will spit out configuration for MRTG to create log or the graph files. Peer-to-peer graphs can come out of it straight away, and you don't need to do anything. Once you set these things up, this sort of ecosystem around IXP Manager, and all the documentation is there for it. Once you've added that interface, all of this stuff will kick off and be built on cron jobs or wherever else you're kicking it off. Same for smoke ping, Nagios monitoring, AS112 sessions. So if you've got an AS112 service at your exchange, you can have that auto provisioned from IXP Manager. The reason it was looking for a host name is because you can configure your ARPA DNS, because the IP address we allocate is, of course, the IX's IP address. We can update the IX's IR, ASZ and ASN objects and more. At INX, and we've got presentations and documentation on this. We actually provision our switches from IXP Manager's database. Okay, so we're going to get onto root servers now. Just look to see if there's any questions. So someone is asking, can we use the software stack for our private network use? The answer is you can use IXP Manager for your private network use, but IXP Manager is particularly targeted at internet exchanges. So if you have a private exchange, and for example, IXP Manager is used by some government networks. I know of one or two. I just don't know if I can say who they are. But for example, if you have a typical government network connecting agencies and departments would normally involve access providers, so ISPs. And IXP Manager, I know, is used by some government networks where the ISPs hook in and advertise the prefixes of all of the customer departments and whatever agencies that they're connecting. So IXP Manager can definitely be used in private use cases, but that private use case has to relate to being an internet exchange of some form. Okay, so root servers. as I say, most of you probably have a good idea what a root server is, but just to give a quick recap, it's a third-party brokering system. And, BGP is usually bilateral, it's peer-to-peer, whereas a root server is a multilateral peering system. And the reason they exist is because the BGP sessions required for a full mesh peering at an internet exchange point grows exponentially with the number of members. So, if you only have 10 members, if everyone was to peer with everybody, that would be 45 sessions. If you have 100 participants, that would be nearly 5,000 BGP sessions. So that doesn't scale. And particularly, you got to think of, of your 100th member. That 100th member would have to go knocking on 99 doors to get their full mesh session. Whereas if you have an exchange where typically 80+% of members are going to use a root server, they've only got 20 networks to consider rather than 100 networks to consider. And of those 20, most of them are probably going to be very selective for peering. And the answer will be no anyway, Graphically, this is what the problem that root servers try to solve. On the left, we've got 8 participants, with a full mesh peering session, and on the right, we've got the root server cluster. So when you join that exchange, you just connect to the 2 resilient root servers, and straight away you're passing traffic. You get very quick reward for joining the exchange rather than having to wait for N networks to configure BGP sessions. So, in a multilateral BGP peering, what we mean is that the routes that a member will announce to the root server will be forwarded to all of the other participants of the root server cluster. So if there's 5 members, if a member advertises a route in, that gets sent to the other 4 members by the root server. But the important thing is the root server does not forward traffic. It doesn't act as a router. It just exchanges the BGP information. And particularly what you note with a root server is root server has its own AS number, but in the BGP routes that it sends to everybody, that AS number doesn't appear in the path. So it looks as if you have all of these bilateral peering sessions. You just got this root server brokering that information for you. There's 2 RFCs. They're linked here. Nick Hilliard, who is the CTO at INEX, is one of the authors of those. So if you want more information on root servers, you can find those there. So in terms of an IX, root servers are considered to be a production level service. In a modern internet exchange, there are 2 critical services: that your peering LAN, your peering fabric works, and that your root servers work. So they are considered production level service. If INEX's resilient root servers stop working today, we'd probably see an 80 or greater % reduction in traffic. So they need to be designed carefully. They need to be resilient, and they need to be, secure. The reason we talk about securing root servers is that you got to remember that the service you're providing allows one member to inject routes into the routing table of all of your other members that participate in the root server cluster. So you as an IX operator have a huge responsibility when you run a root server, because you can create an awful lot of problems for your members if you don't secure those properly. And remember, threats can be malicious or accidental, and it's important not to attribute maliciousness to anything bad that happens at a root server, because in 99% of the cases, it's just going to be PEBCAC. Some poor network operator has fat-fingered a configuration, and they've leaked a default-free zone or a default route or something like that. And it will definitely be 99% of the times it will be accidental. And I suppose one of the things that we've learned from operating a root server for nearly 15 years is the perceived importance or skill or size of the network is irrelevant to accidents happening. We've seen some of the biggest networks leak a default-free zone, and we've seen some of the smallest networks leak a default-free zone. So don't assume because it's a big network with a well-known name that they will be okay. We've seen it go wrong from any size of network. The kind of threats that can happen would be, a root leak, default rezone, default root, or targeted network. Maybe someone is being malicious and they advertise Google's routes, for example, to try and capture some of that traffic. Next hop hijacking, and then of course root server software bugs. So that is why you should probably try and run 2 different software stacks when you're doing your 2 root servers. I suppose the question that I'm trying to answer in this slide is, why should you trust us or IXP Manager to configure your root server configuration? And to try and give some comfort on that, what I would say is that INX has operated root server since 2007, so 14 years. Our CTO wrote the 2 RFCs, co-wrote the 2 RFCs that cover root servers. We've given countless presentations, workshops, tutorials on not just on root servers, but on BGP and anything in and around that ecosystem. At INX, root servers have always been automated. So never in the history of INX has a root server ever been manually configured. So our expertise in this area is from day one, from 2007. Whenever we spin up a new member, whenever someone has a problem, we never ever go in and manually configure a root server configuration.
Sorry, can I just drop in here, Barry? We've got a question in chat because this one sort of relates to what we're talking about. What OSs does it support, and are there any customers that run it on microkernels?
Yeah, thanks, Dave. So what OS does it support? IXP Manager will run on any Unix-based operating system. It's a PHP application. I imagine you could run it in Windows. I've certainly never tried. But the requirements for IXP Manager are Linux or FreeBSD. We would typically recommend Ubuntu Server 20, like whatever the latest LTS long-term support release is. That's how what all the videos are geared towards. That's how we run it at INX. But it will run on any Linux or BSD. It just requires the current version requires PHP 7.2, I think. The next release that we're going to do, and in fact, what you're looking at on my screens is the next release, which will be IXP Manager version 6. That will require PHP 8. It requires MySQL. I think they're the main requirements. For the root servers, IXP Manager will create configuration for Bird v1 and Bird v2. We are going to try and release support for Open BGPD this year as well. It used to support Quagga in the past, but we stopped doing that a few years ago for various reasons. We can get into that later in the Q&A if you want to. So I know I've just said that you should have 2 software stacks if possible. If possible, it became difficult a few years ago. So at INX, we've run it on Bird for 2 Bird instances for years. We've never had a software problem with Bird, and we're quite conservative in upgrading it. How can we set up and manage multiple redundant or clustered IXP root servers? I suppose we get onto that in a little while when I show you how we actually build a root server. You'll see how easy it is, and then you can see how easy it is to create multiple instances of it. I think that answers that okay. Yeah, so I think just to close off this slide, this sort of trying to give comfort into why you could trust IXP Manager to do this. All of that experience has been distilled into IXP Manager, so it's part of the configuration templates, which again we'll see shortly. This is just from a historical context. This is Nick Hilliard's email to the INX membership in 2007 when INX first launched our resilient pair of root servers. And there's 4 elements to this email, the 4 points, which are still as important today as they were back then. The first thing is that root servers are a multilateral peering platform, and we've discussed that, how it's not bilateral, it's not one-to-one, it's one-to-n. From day one at INX, strict filtering, and we've sort of mentioned some of the threats, and we're going to go through more threats in a little while as we show you how we do this filtering at each stage. We talked about being dual hosted for resiliency, and then the other thing that we haven't touched on yet is community-based filtering, which we'll have a quick look at now. So one of the things with root servers are that you are to some degree taking control away from your members. If two networks have a bilateral peering session, they can put a lot of filters on they can do AS-PAP prepending. They can send some routes, but not all routes. Whereas when you're doing it to a root server, whatever you send in and goes to everybody else. And that will dissuade some people from using them, especially larger, more complex networks. So it's important that you allow your members to control how their prefixes are propagated to different members of the root server. A typical example is, there's 10 people on this root server cluster. I want to advertise my prefixes to 9 of them, but not the 10th. How can I do that? And to do that, we use what's called well-known community filters. And just on the screen here, this is just what do I mean by communities? It is what I mean by communities is the standard BGP community. So just a tiny bit of a Cisco snippet where you might have a route map and you might set the community 65501, 65502 on the routes that you're advertising to the root server. Right? So that's what it's just standard BGP communities and large communities. There's a huge amount of documentation on this on our. Sorry, not a huge amount. There's some documentation on this on ours, but there's lots of resources as well on the internet about community filters. And I've got more here too. There is pretty much the reason we call them well-known community filters is there's pretty much an evolved standard now of what these community filters are. So these standard community filters, which standard 16-bit communities, there's 4 of them. So if you wanted to stop your prefixes from being announced to a particular AS number, you would tag them with 0:, whatever that target AS number is. If you want to announce your route to all peers, you just tag your routes, the root server AS, the root server AS. You don't have to do this. This is a no-op. This is a default behavior of the root servers. So in practice, nobody ever does that. So a very good use case is, I don't want to announce my prefixes to anyone except AS, X, Y, and Z. Well, then I would tag it 0 with the root server AS number. So prevent announcement of a prefix to all peers, 0 root server AS number, and then accept ASX, ASY, and ASZ. So I give it 4 tags, and that would allow me to achieve no one but networks X, Y, and Z. Similarly, if I wanted to do it to everyone except X and Y, because that's a no-op, I don't need to do that. I would tag it 0x, 0y. I see someone's asking, does the IXP Manager reside on the root server or does it have its own cluster? Separately. So IXP Manager will be on its own server, and then you will run the root server separate to that. And again, I've got a demo system here, so I'll explain a little bit more around that when I get there. What is the criteria of IXP Manager server scaling? Asm, you might jump in maybe and just give a bit more detail on the question. I'm not sure if you're in terms of scaling, if you mean how many can it support. IXP Manager is in use with exchanges that have 300, 400 networks. So there's no particular problem with IXP Manager. Typically that comes down to the root server software, but Bird is in use at exchanges like AMSIX and DKIX and Links. So it will scale to the largest exchanges that already exist. So I don't think there's a particular scaling issue. So one of the things that is really important about community filtering is as the years have gone on, 32-bit AS numbers have become far more prevalent. And the standard communities are absolutely useless for filtering when you have participants with large communities. So, sorry, with 32-bit AS numbers. So for those, you're going to have to use large communities. I think it's fair to say now that in 2021, most modern routers support large BGP communities as well. So the issues that might have existed 3-4 years ago around this are mostly solved, and most people should be able to use large communities. Again, there's the set of standard tagging for large communities, and they all work the same way as the previous ones. One important thing to mention is that while if you have a member that has a 16-bit AS number, and maybe they're using an older router software that doesn't support large communities, they can use standard communities, but they'll only be able to affect announcements to members with 16-bit AS numbers. They won't be able to affect announcements to members with 32-bit AS numbers. But it's also important to advise them to not mix and match. If a router supports large communities, they should just use large communities. But they shouldn't try and do a mix of large and 16-bit communities. That just won't work properly. And then just the last thing on standard communities is there is a bonus with large communities. We can do more things with these. So with the 16-bit standard communities, we only have 2 bits of 2 buckets to put information in, and they're limited to 16 bits. So we can't do very much with those. But with large communities, we have a 3rd bucket. So now we can use that middle bucket here to do additional things. So in the previous slide, we use it to say don't announce or do announce. In this slide, we're using it for other things as well. So we're saying if you tag it with 101, you're telling the root server to, when you send a route to this network, prepend URAS once, twice, or 3 times. So we get this bonus for large communities that we can allow even more control to the members in how their routes get announced to different root server members. Okay. So I'm going to check the time. Okay, 44. Right. We're going to start looking now at root servers in a bit more detail. And to do that, I just want to talk about Bird being the root server software. It sort of topology that Bird has when it comes to how we've designed root servers within Bird. So in the master routing table is basically where all of your root server clients prefixes end up. They'll all end up in the master routing table. Bird has this concept called a pipe, where you can pipe routes between different routing tables. So in our design, every two gets their own dedicated routing table, and we're going to see this slide or this version of the slide a few times. So you will. So from all of the other members, whatever routes have ended up in the master routing table, we've decided that they're clean. Now, when we want to get those routes, all of the other members' routes, we want to send those to AS112. We've got to pipe them in reverse. We've got to pipe them back into AS112's own routing table, where they'll then be exported to AS112. And it's at this point, as the routes move from the master table to the AS112 table, that we apply that IX Community Filter. So if a particular network had tagged their routes 0:112, that would have meant don't advertise it to AS112. So as that route came into the master routing table, and then as it gets piped to AS112's own routing table, that would have been filtered here. That 0:112 would have stopped us putting that route in here, and so it wouldn't have been available to end up in AS112. To be exported to AS112. So again, don't get too caught up in this. We're going to come back to the slide a few times, and we'll see it in a bit more detail. So what we'll do is I'll just go on a tiny bit more, and then we'll take a break. So we're going to start looking now, getting into the sort of more technical elements of this presentation, and we're going to start configuring root servers with IXP Manager. So to create a root server, what do we need? Well, we need an AS number. And what we always say, what's really important is that at an IX, you might have an AS number for your management prefixes and your peering LAN and things like that. You should have a dedicated AS number for your root server that's only used for your root servers. You're going to need a peering IPv4 and IPv6. So that's just the IP addresses on your own Internet Exchange LAN. You need a router ID, same as any BGP configuration, usually just a v4 IP address. You need your BGP software. So as I mentioned, IXP Manager has Bird v1 and v2 baked in. What I would say to you is if you're setting up a root server at IXP Manager today, use Bird v2 because RPKI isn't supported in our configurations in Bird v1. Bird v1 did support RPKI, but it's a little bit awkward to configure because it required you to actually put all the RPKI entries into the configuration rather than getting it through a validator. So use Bird v2 if you're setting up a root server today. Will you support MD5? You should do this because on a shared peering LAN, many networks will require MD5. You should, of course, use large communities. Enabling large communities won't break anything for any network that can support large communities. So there's absolutely no reason not to support large communities from day one. It won't affect any network that doesn't support it. In 2021, of course, you should be using RPKI and you should also build a looking glass. So we then add the router in IXP Manager. So let's take a look at this. So in IXP Manager, on our IXP admin actions, we have routers. Right now, I've got none defined, so I can go and add a router. Now, again, just to make an important point here, documentation tag is here. When we click onto it, you can see here it's sort of a mirror of this page, and it's going to talk me through all of the details, how I configure configuration, how I set it up in my servers and stuff like that. So essentially what we're going to be doing is going through what's in this documentation. The key thing is that documentation is available. And again, of course, the help button is available, which gives us a lot of detail here. So I see Mohammed is asking how to add a router and switch in IXP Manager. So Mohammed, I'm showing you right now how to add a router. I won't be showing you how to add a switch. It is here. You can add a switch. There is documentation for it, but it's not really, I'm afraid it's not really in the context of what I can cover today in the time allotted. But how you add a switch is an option here. It is done quite intelligently. When you go to try and add a switch, it just looks for host name in the SMP community. So it tries to discover the ports and everything, so you don't have to do that stuff manually. But what we are going to go through is how to add a router. So when we're adding a router, one thing we need, and you'll see that this is quite important, is we need a handle. In the handle, our way of naming these in INIX has been RS1 or RS2 dash IPv4 or IPv6. Because INIX has 3 LANs, we would normally put in LAN 1, LAN 2, or Cork in there. So whatever's appropriate to you, but if you're just running one exchange, the root server number and the protocol is probably all you need. Choose your VLAN. Again, INIX, we've got 3 of these. We've got Peering LAN 1, Peering LAN 2, and Cork. If you just have one, just pick the one you have. Pick your protocol. I mentioned earlier that IXP Manager can generate a number of different configurations, including root collectors and AS112. This time we're doing a root server, so that's why we're selecting that here. We're going to give it a name and a short name, and in this case, the name and short name are the same because we're not putting in any huge amount of information here. You could have put in something like, actually there's a type in there. You could have typed it right out. Root server 1, IXP LAN 1, IPv4. But in this case, we're just going to keep it short and sweet. We need a router ID. Again, I said that's probably going to be the same as your IPv4 peering address. And again, that is going to be my peering IP address. On my demo system, I've just configured, I've just used the documentation prefix here, a /24 for my peering LAN. So at INIX, we have always historically used .8 and .9 for our root servers. You can use anything you like, but just that's why I picked .8. It's just that what we've done historically. I said you would need a dedicated AS number for your root server. I'm just using an example one here. Now, the platform software, this doesn't affect the configuration anyway. This is purely for informational purposes, as is this. You know, when the export for the IX Federation or URIX, the IX JSON export, this information is included to try and build up some statistics of what software and software versions IXs are using for their root servers, what operating systems they run on. Again, this is just purely free text informational. It won't affect the configuration at all. And again, that information is contained within the help. So like if I enable the help here, it is telling me, look, this is free text, free text, free text. So I know it's not critical, and it won't affect the configuration. The management host is an IP address to which we can address the root server itself. So someone was asking earlier on, you know, how would you put IXP Manager on the same host as your root server? The answer here is no. You know, for example, if you take INEX, for example, we have two main servers we run, which we virtualize. So we use XCP-ng, which is a version of Zen server. You can use VMware or whatever. And on those servers, we have various virtual machines that we run. And one of them would be a virtual machine dedicated to IXP Manager. And in the installation videos, I talk about the requirements in more detail. But you know, you don't need anything particularly strong. 4 GB of RAM, maybe a dual-core allocated dual-core CPU, maybe 30 gigs of space for /SRV. Is loads for any, you know, small to medium-sized exchange. For the root servers, they'll run absolutely fine on a virtual platform as well. But at INEX, we have traditionally used, because they're critical infrastructure for the exchange. At INEX, we have treated them as such. So we've used dedicated servers. So different to the 2 virtual servers I talked about, we have 2 dedicated servers for running root servers. We virtualize those as well. Virtualizing the root servers is great because it means that in a maintenance window, when you're upgrading the software, you can clone outside the window, you can clone the virtual machine, you can do all your upgrades, you can do your tests, and then when it comes to deploying the new version of your root server, you can quite literally swap the network interfaces, and if anything goes wrong, rolling back is just swapping the interfaces back. So we have dedicated hardware for root servers, and they are, you know, dual PSU, and they're in different physical data centers. So those things are all important. Our root servers all have an interface, dedicated interface onto our peering LAN, but they also have an interface onto our management network. And that's what we're talking about here. What's the management network of the root server? Now, in terms of API type and API endpoint aren't important unless you're going to be putting on a looking glass. And we are going to be putting on a looking glass. And the looking glass we're going to use is what's called Birdseye. And the endpoint for the looking glass is basically your management host name. So in this case, RS1-IPv4 will resolve on my system to this IP address. The looking glass privileges is, for example, if I come onto INEX's own IXP Manager, so this is the dashboard for INEX. If I just log out of this, the looking glass is available to me, because when I say what is the minimum privilege, I said public. So I said that people don't need to be logged in to look at INEX's looking glass for our root servers. And that's what it's asking here. Again, when you click help, that's all explained. This will not be used for quarantine. So at some exchanges, when new members connect up, they go through a quarantine process. So that won't be used for quarantine. We will enable large BGP communities because, as I said, you don't lose anything, you don't affect anything, you only gain by supporting large communities. I'm not going to enable RPKI now. We're going to come back to that in a little while. I am going to pass through well-known communities such as no export. That's It's a longer conversation, which we're not going to get into now. But again, drop down help or look at the documentation, and that will be well explained. I'm not going to skip MD5. I want to support MD5. And then the last thing is the template. And when you click help, it pretty much tells you what you can use. So for Bird2, we've got a template for root server, root collector, and AS112. But the fact that you can configure this, it allows you to create your own templates for root servers as well. But mainly, the important thing is when you click help, you can just copy and paste a template into that. We can create our root server. Now, we're going to pause in about 2 minutes just to finish off this section. Just to finish off this section. So I've created my root server. Do you know what? Actually, we'll take a break now. It's just coming up to, 7 a.m. my time. It's just coming up to the hour. So let's say we take a break now for 10 minutes and we come back. We start at 10 past the hour sharp. I'm going to go get a coffee myself. If anyone has any questions that they want to throw in, I'll just go grab a coffee. I'll come back and I'll answer any questions up until 10 past the hour, and then we'll pick it up from this point again. All right. Thanks very much.
So yeah, questions, everyone. Make sure you put them in the Q&A box. Don't throw them into chat. So that way we've got a log of them all and we can make sure we're not missing anybody.
Hi, folks. We just give it one more minute. We'll go back. In the meantime, I see there's one question in asking about communication between IXP Manager and the root server. Is it encrypted? If yes, is it on the transport layer? So the only configuration between IXP Manager and the root server, sorry, the only communication between IXP Manager and the root server really is for the root server to pull the configuration down, and then sometimes for interrogating the looking glass. For interrogating looking glass, encryption isn't particularly important because that information is going to be displayed in the front end anyway. But also gain the configuration. I suppose there's two elements of security. One is the fact that this should be on your own private management network, so it shouldn't be over the public internet. But if you wanted to host IXP Manager, maybe on a public IP address, that communication should be done over HTTPS, and you'll see how we pull the configuration in a minute. So it will be transport layer security, you know, clearly if you're deploying IXP Manager, we would absolutely recommend that you put it behind an SSL concentrator, or that you configure Apache or Nginx with SSL.
I have a question, seeing as I can't actually ask a question in the box. You said this is version 6 at the moment you're demoing. Is there going to be a script to go from 5.x up to 6?
Yeah. So, I mean, if anyone is using IXP Manager, I think one thing to note is that they won't actually notice any particular difference on the UI. So version 6 is very much massive changes under the hood. The migration will be relatively easy. I don't know if we'll create a script. We may very well, because I think it probably is easy enough to create a script. But what we will do is release it with a video where I will show a production system being upgraded from 5 to 6. I think the biggest catch for anyone moving from 5 to 6 is going to be the requirement for PHP version 8. But you know, if you're running on Ubuntu, which is what we suggest people do, it is actually quite easy to even without upgrading your Ubuntu distribution, it is actually quite easy to install PHP 8.
Cool, thanks.
So what we've done just before we stopped, folks, was we added a root server to IXP Manager. We went here, we filled in the form, and essentially what we did was we just created a database object that represents a root server. And you know, that's great, but the question is, how do we use that now? And just, it's important to note that what I'm still doing here is I am pretty much following the steps that are laid out in that documentation page. So if you do fall behind, ask a question, or remember, this stuff is pretty well documented. So what we have is this router added to IXP Manager, this root server. On our actual root server, we need to get that configuration. And to that end, IXP Manager has an API interface. So under my account, you can see API keys here. And again, just a reminder, straight away, you've got context help right there, bringing you to the API documentation. I've got a key created already, which is the key I'm going to use for this. But if I wanted to add a new key, that's no problem. Just give it a description and create it. And there's my new key. You can see they're kind of hidden from view here, but if I put in my password, if I remember what it is, excellent. If I put in my password, it will show me the keys in their full version. And remember, of course, that an API key is like a password, so it gives full access. And the reason when you come to this page that they aren't shown by default is just to stop anyone browsing, you know, finding your open browser and getting your keys. So you have to put in your password to get them. So I have an API key. I'm going to use that to get the configuration that I have. So I'm going to go onto my command line here. And I have just a few bits that I have gotten ready already. So let me just paste this in. So I've just created a variable with my API key, my URL, and you may say, where am I getting this URL from? Well, it's in that documentation page. So it's whatever your IXP Manager endpoint is, /API v4 router genconfig. And I've got a handle. That's the handle that I used. Remember, I said that handle would be important later. So when I created my router, I gave it this handle. That's how I uniquely identified a router. And now I'm going to use curl to pull the config. Just paste that in here. So here's my curl command. I'm sending a header with my API key, the URL I have above, which is this guy here, and my handle. And I'm going to pipe the result to less just to see what it looks like. Oops. And there it is, that quick. So just curl. There's my root server config. We won't look at it here. Just to make life a bit easier, I can also look at it by clicking on this icon in IXP Manager. So here is my root server configuration. What we have here is an awful lot of boilerplate. Time format, how Bird what time format it should use when it's giving its output. And the reason we set that is for the looking glass to parse. I defined some variables that we're going to use throughout it. So my root server ASN and my root server address. And that comes straight from the stuff that I typed into IXP Manager. So it's straight out of IXP Manager. There's my router ID, typed straight into IXP Manager. We're going to see some stuff later, and we'll probably go through more detail then. But as I created IPv4 root server, I've got all my IPv4 Martians or bogons all configured here. We'll come back to some of this stuff in a little while later. Again, a lot of this is boilerplate. Here's my IXP Community Filter. So this is what I was talking about earlier on, about how we can prevent announcements to certain peers. This is the filter that gets used for that. And again, we'll come back and have a look at this in a little while. I did not enable RPKI, as you might recall. I defined some transit ASNs, and we'll come back to that as well later. And then at the end, root server clients, I've got nothing in there. Okay, I've got a little template here for my RS for root server clients. My local AS is whatever my root server ASN was, that was defined higher up, 65505. My source address defined higher up again, 192.2.8. We're going to overwrite this in the clients, and I'm just telling Bird that this is a root server client. That tells Bird to do certain things, like make sure that we use a per client router RIB, router information base, routing table. So it's, because I haven't enabled any clients, what we have here is boilerplate essentially, and it's sort of the elements that we'll use later to build up the configuration and make it useful. What I'm going to do is I'm going to turn on a client now. So I'm going to go back to IXP Manager, and I'm going to go to my members, and I'm going to go to ports. I'm going to edit. I remember I said that root server client and IP addresses are all defined in the Vlan interfaces. I'm going to edit that here, and I'm going to click root server client. So I'm going to turn that on. I'm going to save that. And if I now go back to my routers and I go back to my client config, let me just make this a little bit bigger again. I go all the way down. Before, where I had no root server clients, I now have a root server client. So this is for the network I just turned on there. You can see, if you remember, I said that we always have a per client routing table, and that's what I'm defining here, the routing table for this client. I've got an import filter. I've got an export filter. I've got the pipe that we talked about, and I've got the BGP client configuration itself. Now I'm going to break this down in the next few slides, but I just want to say what's important here is that this stuff is quite complex, and if you haven't used Bird before, do not expect to be able to understand this in the confinements of this webinar. The important thing is that the webinar is being recorded, and you come back and look at it again later. Or if you've never seen Bird configuration before, just try and get a handle on the basics without getting stuck or worried about the nitty-gritty stuff. So again, one of the things I did say I'd be showing this a few times, and the important thing to remember here is that we have a root server client. So someone, a network, who is creating a BGP session to our root server, and our root server is this green area here. So we have some IX client. They create a BGP session, and that session comes into that protocol BGP, which is going to import and export from this dedicated routing table for this particular client. And the routes that are advertised into this routing table are piped through this filter into the master routing table. And in the reverse, the routes from every other client are piped back through this other filter into the routing table and then exported to the client. So the elements that we will be looking at is the configuration for the client itself and how we import and export routes from and to the client. And then we're looking at the pipe and how we import and export routes between this routing table and the master routing table. So that's the bits that we're going to be looking at here. So the BGP protocol, the actual configuration that allows this network, this router, to create a BGP session to our root server. Like any BGP configuration, we've got a neighbor IP address and AS number. And sorry, actually, just to highlight something here, the graphics I'm using here are talking about AS112. They're graphics I've used previously. In my sample configuration here, I'm using AS1213, and that is, I'll just turn that on here, HEANet, ports. And in fact, I'm not going to stop there. I'm going to just enable the root server for all three of the networks I have so that we can see full multilateral peering. So let's turn on the root server for all of them. And if I go back to my routers and look at my config, scroll right down, you can now see I've got root server clients. I've got AS1213, SkyTel, and Aptus. So all of those configurations have popped up. And the one that we're looking at here in my slide deck is going to be the one for AS1213. So on my demo system, I've given it the IP address .32 AS1213. The import limit, the maximum prefixes. This is if this client sends me more than 100 prefixes, I'm going to tear down the BGP session and then I'll restart it after, I think it's something like 5 minutes. If, as an IX client and you set up all of these bilateral sessions to the other members, again, the same as peering with a root server, when you peer with someone, you're putting your network at a little bit of risk, lest that BGP peer sends you some bad routes on purpose, maliciously or not. One of the best ways, the easiest ways to protect your network is to always set a prefix limit to some appropriately low value. So this is what we got from PeeringDB for this for AS1213. So it's nice and low as we can see. When we tick that box, enable RFC 1997 well-known communities, that's what gets interpret communities off was put in. That's communities like no export. Again, it's on the documentation. Unfortunately, I just can't get into the detail of that now. The MD5 password on the session is configured here. The fact that remember, I keep saying that every peer for a root server has its own dedicated routing table. And this is how we define it here. It's not table master. It's this dedicated table for this particular member. Now we have an import filter. The import filter works, whatever AS1213 advertises to the root server, that's what goes through the import filter. And now we're going to look at that here. The import filter, just in our configuration, it's quite large. I'm still going on. All right, so it's quite large here. This is the meat, the very main elements of securing a root server at an internet exchange is your import filter. So we're going to spend a bit of time on this. Again, remember, if you haven't seen Bird before, you don't need to get bogged down on the configuration. This has been recorded and you can always look back at it again. So we're going to go through a lot of steps in securing our root server. The first thing we're going to do is we're going to filter small prefixes. And by default, what that means on IXP Manager, and it's configurable, is that we won't accept any network that's smaller than a /24 for IPv4 and anything that's smaller than a /48 for IPv6. If the network that has been the root, the prefix that has been advertised is a /25 to a /32, we're going to internally within the root server, we're going to add a community to that root, to that prefix. And that is defined as IXP LC filtered prefix len too long. What is this? Well, if we go back to our configuration, we go back up, one of the things I said we come back to is all of these definitions here. And the one we're looking at here is len too long. So it's this one here. So I'm tagging this prefix with whatever the root server ASN is, which was defined above, 65501. The middle element is 1101, and then the particular element to identify length too long is 1. So I'm setting a large BGP community tag on this prefix for root server ASN 1101.1. That is exactly what I'm doing here. And I'm accepting the root. Now, you might be very confused all of a sudden. Hang on, you're meant to be filtering these, Barry. Why are you accepting it? Remember, I'm accepting it into AS1213's own dedicated routing table. It's not coming into the master routing table at all. It's only getting into their own routing table. And the reason I want to accept it is later I want to show 1213 what prefixes I'm filtering and why. And if I don't accept it into their routing table, I'll never be able to show them what I'm filtering. It'll just be rejected at the edge of the root server. So I'm tagging it for filtering later, and I'm accepting it in. So as we step through this, these are all the checks that I do. The next one is, if you remember our Martians, that was our table of bogons here. I'm seeing if the prefix is a bogon. And if it is, I'm tagging it for that. And I'm moving on, I'm accepting it. This is sort of a belt and braces check. If as a network I advertise a prefix to a root server, the first AS on the BGP AS path should be my own AS. If it's not, I'm tagging it for filtering and I'm going to move on. When I say move on, I mean move on to the next prefix. I'm done with that. I've tagged it, I've accepted it, I'm finished. Next, BGP next hop hijacking. This is where maybe I'm a small network in a large geographical country. And maybe I've got a POP on the West Coast and a POP on the East Coast. And maybe it's really expensive for me to transit traffic between my two POPs. Maybe that's a really expensive thing to do. And maybe there's a bigger network that has lots of POPs all over the country. And maybe they're part of the IX on the West Coast, and they're part of an IX on the East Coast. What I could do is advertise my prefix into the exchange, but instead of saying that the next hop to this is true me, maybe I'll say it's true this other network. And that other network could carry that traffic for me and pop it out into the IX at the other end and give it to me over here. So I'm abusing another network to transit my traffic between two of my locations. And that's what next hop hijacking is. So what we do here is we make sure that the next hop, the gateway for this prefix, is the network that's advertising it to the root server. Now, that network might have multiple connections to the exchange. So IXP Manager is creating a set here of all of the IP addresses that this network has at my internet exchange. In this case, it's just one, but there might be more than one. Some networks appear 2 or 3 times on an exchange. If the network is within, so first of all, I'm only concerned if the next hop address isn't the BGP peers address. So that's what that if is here. If they're not the same, but if it's within that network's IP addresses, I'm just setting an info tag. An info tag is different to a filter tag. So these are the filter tags. This is an info tag. Instead of 1101, I've got 1001. All of the 1101s will be filtered. The 1101, the 1000, these won't be filtered. They'll just be used to provide information in the looking glass later. Otherwise, it's hijacking. I'm setting a filter tag. Okay. Now, we had these known transit networks. These are our transit networks that have said that their AS number should never appear in the AS path of a route advertised at an internet exchange. So if their AS number is in the path, the chances are we've got a route leak going on. And that's what we're doing here. And you can see there's no filtering tagging going on here. That's because I actually do that within the function itself. Filter has transit path, tag it for filtering. I appreciate I might be going a little bit fast here. again, as I say, this is being recorded and the slides will be available afterwards. But I just want to get through this, not too fast, but you know, with a bit of expediency. Belt and braces, if the AS path has more than 64 hops, it's kind of weird. We're going to filter that out too. There was a situation in the past where a network advertised an AS path with more than 256 AS elements that crashed a number of BGP speakers around the internet. We didn't enable RPKI, so we're checking that. We haven't done IRRDB filtering yet. We're skipping that. And then the last thing is we accept the route. So at this point, it hasn't been filtered, and we're just going to accept it. Sorry, in the previous ones, by the way, we were adding, for RPKI, we're adding an info tag, RPKI not checked. An info tag, IRRDB not checked. So those checks, that import filter, this happened as the BGP client was advertising their routes into the root server. That's where all of those checks happened. Remember, we accepted everything in here, except we tagged anything that we didn't want to let into the master table. We tagged it with a 1101 tag. They got filtered here. They do not make it to the master table, right? But they do come into the client's own dedicated routing table. The export filter. This is about filtering routes that are in this table as we send them to AS112. The only routes that are in here that we're going to send to AS112 is stuff that has made it from the master table through this pipe into this. So they're clean. But what they will have is all of these tags that we've been adding, all of these info tags that we've been adding may be on those routes. So all we want to do with the export filter is we want to strip off those tags. And that's all we're doing. We're stripping off any tags that have the root server ASN as the first element. Just delete them and then send the route back out. So just removing all of those tags that we added to clean the routes. Now what we want to do is a pipe. So if you remember, I kept saying the client has their own routing table, and then there's a master routing table, which is all of the clean routes. And anything that needs to go from, that we've gotten from the client has to go through the pipe into the master routing table, and then anything in the master routing table in reverse has to go through that pipe to get in here. This is the pipe. So this pipe is a dedicated pipe between the master routing table and this peer's own routing table. The export to master, remember I kept saying that anything in here that we're going to filter was tagged 1101, and those tags would not get through this pipe. That's exactly what this is, the export to master. If the route has a 110 tag, 1101 tag, it's rejected. Anything else is accepted. And the stuff in reverse, if you recall, I said anything that's in here is clean. And that community filtering, maybe a network in here doesn't want AS112 to get the route. That's the IX community filtering. That happens in this direction. And that's what this tag is here. It is only exporting where this returns true. And that is this guy here. And just as one quick example, you can see it returns false, true, true, false, true, false. So it returns as appropriate. That was the community filtering tags. Sorry, I actually have a particular slide on that. You can see if client AS65503 tagged their prefix 101.12.13. I'm just conscious of time. I don't want to get into too much into the weeds in this stuff, but and we've covered community tagging earlier on. You want more details? It's in the slide. I think we've covered enough on it. I think we'll just move on from it. Huge amount there. Let's regroup a little bit. So we now know what root servers are and why they're needed. We have an understanding of why they need to be secure. We're conscious of the IX's very important role in this. We have seen how IXP Manager generates the configuration. We've examined the basic structure of that config. We've gone through all of the kind of boilerplate stuff, and then we've looked at a client configuration. We've looked at the import rules and the tagging that we use to say why a prefix is filtered and how it's filtered. We've examined the standard communities about how we can stop routes being advertised to particular peers. We've got a basic understanding, I hope, of bird topology in terms of the client's routing table, the pipe, and the master routing table. And we have a working root server configuration. Now, how do we build a root server? And this might seem like a very complex thing, but this is actually not that complex. So what I'm going to do is, I have my root server here. Okay, let me just do a ps-ef grep for bird. No bird running, no root server exists. So what I'm going to do is walk you through the steps here very quickly. So I just did an apt install bird. Now, bird will start, this operating system will start bird and it's got its own default configuration. I don't want those. So I'm doing a disable bird, and I'm going to stop it, make sure it's not running. Okay. Again, you might be saying, where am I getting this stuff from? This is all in the documentation. So I've installed bird, but I've stopped it from running because I'm not interested in the operating system's configurations. I'm going to be interested in our own. So I'm going to go off to our own user local SBIN. On IXP Manager's website, on GitHub, and again, this is all referenced in the documentation. We have, sorry, this is just inex/IXP Manager. We have a tools directory in which we have a runtime directory, in which we have a root servers directory. And in here, we have a file API reconfigure example bird v2. This is a bash script that you set a couple of parameters and it will download the configuration, start or reconfigure bird, and do all the right things to make sure that your root server is up and running. And let me just show you how easy that is in real life. I'm going to take the raw version of this file, copy link, just do a wget. So I've got that file now. I'm going to rename it. So I'm just going to call it API reconfigure RS1. And I'm going to edit it. Go to the top. The bits I want to change is the key, my API key, and my two URLs. And you can see really it's just where you've put IXP Manager is all that's changing. So I'm just going to drop in my own demo system here. My key, my URL, and I should have mentioned, by the way, my demo system. I'm running VirtualBox on my laptop. I've got a Ubuntu virtual machine for IXP Manager. That includes my database and anything else I need. I've got a dedicated VM for my root server, which is what I'm operating on now. And I've set up 3 virtual machines for root server clients. We'll see those shortly. So I'm on the root server here, and I've put in my key, which we saw earlier on, how I got out of IXP Manager, and then just my URLs where IXP Manager exists on my demo system. Now, I'm going to make that file executable. Now I'm going to run it. And what this requires is a handle. So the handle, I've told you when you created it, was always going to be important. My handle was this. Okay. Now, I've ran it. What's after happening? Let's see if bird is running. Look at that. Bird is up and running. So it has downloaded the configuration. It has ran it. You will see by default, it puts the configs in user local, etc. bird. So you can see there my configuration. The socket is based on the handle. So if I want to interact with bird on the command line, just do this. Sorry, did I make a mistake on there? Bird C. Sorry, I'm putting a double S. Show protocols. Remember, we should have 3 clients, and we do have 3 clients. And in fact, not only that, you can see that they've all established their sessions. So for each client, we've got a pipe between the master table and its own routing table. We've got the BGP protocol. So show protocols, all. Let's have a look at the BGP. So you can see this one is established. We've got our description. We've got the remote AS with the local AS. And you can see that we've accepted 55 routes. So show route. So here's all the routes, AS 1213 coming in. So you can see, like quite honestly, I hope you can see that that was very easy. Just a few commands. And if I ever, what I would do on my own system is I would put this in cron. Now we have one other script I'm just going to show you. CD, so user local sbin. There is another script. It's called Reconfigure All. And it's a very small script. It's just a tool that we use to, because there's at least two instances. We've got IPv4 and IPv6. We've got at least two instances. You want an easy way to configure them all. So sorry, wget. I'm just going to edit that. All I want to do is basically all you're doing is you're feeding it in handles. And right now we've only got one handle. I'm going to have to speed this up because I'm just looking at the clock. I realize that we may end up running out of time. Sorry. Sorry. The other thing I had to change is the name of the script that I downloaded and put my key in is that script there. So you can see Reconfigure All. We'll go through your handles and we'll do it. And what we would do is we put that in cron job, maybe run it off once every hour, so that when you update IXP Manager, within an hour your root servers upgrade. So look, that was building a root server in much less than 10 minutes, I think. You apt install bird, download the configuration script, edit the URL and the API key, and you execute that script. What are we skipping? Obviously, we haven't done anything about firewall monitoring, your internal documentation. All of that stuff is required for full commissioning, like any service that you would deploy at your exchange. We built the root server. We've shown clients connected, and we've done a show root. We need to get through the next few bits in 20 minutes, so we're going to go really fast here. Again, remember, this is recorded. We need an IPv6 instance. To do an IPv6 instance, we just add another router in IXP Manager. So I'm just going to fly through this, IPv6. It's a root server. It's going to be called this. It's going to be short name that. Router ID, I'm going to stick with the V4 version. My peering IP address is my IPv6. My ASN is the exact same. Bird v2, 207, Ubuntu, 204. Management host hasn't changed. API type is going to stay the same. It's my endpoint. Remember that just resolves to the IP address that I have here on my system. Public access. Large communities, pass through well-known clients, and then the template is a copy and paste of this guy here. Okay, now to make that work, and just to prove to you, I've only got one instance of bird running. I'm going to add this handle to my Reconfigure All RS1-IPv6. So remember, I'm on my root server. I'm in user local bin. I've got the two scripts I downloaded. I've just added the v6 handle to my all. Run it. Now I've got two bird instances. I can look at the v6 one. You can see they're all up and established. Show root. And there's some IPv6 roots. Okay, so it really is that easy. With IXP Manager, full configuration, full features, baked in that fast. The next thing I want to show you is the looking glass. So we have a looking glass. So on GitHub, inex/birdseye. It's a looking glass that we created does this command reconfigure all handles or only the newly added one? It does all handles, but when you run that command, you're talking about this command here. When you run that command for the original handle, it will download the configuration and it will do a diff. And if the configuration hasn't changed, it moves on. If the configuration has changed, it copies the config. You can see old and conf. It copies the config into conf and it tells Bird to reconfigure itself. And it's all hitless. It doesn't affect the clients. Any clients, even if you're adding routes or filters, it won't restart BGP sessions. It'll just reprocess the routes. So it's hitless and it will do the right thing. I hope that answers that question there. Birdseye is just a very simple microservice, a web-based microservice it quite literally runs Bird-C commands on the server and parses the output and sends it back over JSON. It's something that I wrote a few years ago in the hope that Bird would eventually have its own API service built in. It doesn't have it yet, so we keep running it. I'm going to do this really quick. What I'm doing is covered in the documentation here. Okay, so for Birdseye, what I need is on my root server. Sorry. So I'm on my root server here. What I need is some PHP libraries. That went very fast there. I'll just show you what it was. So I just apt-get install some PHP. Again, that's a copy and paste from that documentation. Everything here is a copy and paste from that documentation. While that's happening there, on the Birdseye GitHub page, you got releases. All I did there was I downloaded this bundle. Okay, so that's what my wget was. Downloaded the release bundle. Again, I want to be very emphatic on this because I am going fast. I'm following these steps. Okay, there's no magic here. I'm just following these steps. So I'm going to untar it. I'm just going to create a symbolic link. I'm going to go into the directory and I'm going to make one of the directories readable for the web service. Again, I am quite honestly copying and pasting stuff off that web page. I'm installing light HTTPD, which is a very light web server, so that we can expose this very simple PHP application. I'm going to enable fast CGI and I'm going to enable PHP on that light HTTP. Now I need to configure light HTTP. You might think that this is going to be really difficult. Again, I'm trying to make this, as easy as possible. What happened there was I downloaded sample config off that repository. Look, there's the example. I just downloaded that file, simple as that. I'm going to edit it. I don't even need to edit it, but only thing I'm going to do is, because I just want to emphasize that, on a production system, you should really only have this service listing on your management network. So that's all I'm going to change. We're not going to look at anything else because we don't need to. I'm going to restart the service. Now I'm going to go into Birdseye, and there's a sample configuration, which I need to edit. And I only need to change one thing in here. Again, I'm just working off that documentation on that web page. One of the things I need to do in here is I need to define where Birdseye exists. And that's all I'm doing here. And I need to give it the socket for Bird. You don't know what the socket is, ps-ef grep bird. And there's my socket for IPv4, and there's my socket for IPv6. So I'm just putting that in there. Oops. Get rid of that line. One other thing I'm going to do, you don't need to do this, but this is just so I can just check that this is working. Birdseye has an internal looking glass, its own little web-based looking glass. You don't need it because we use IXP Manager to front end it. But I'm just going to turn it on here just so we can do a quick test. Need to restart. Oh yeah, the other thing is that the web server needs sudo permission to run that command that we just specified there. Sorry. In the config file, we had this command. It's part of the Birdseye distribution, part of the package. We need to give the web server permissions to run that. And again, I'm copying and pasting straight out of that README in GitHub. That's where all of this information is. Now, I need to do something for my demo that you don't need to do in production. So close your eyes for this one and just pretend I'm not doing it. This is just because my demo system has a little quirk. So you can forget about that one. The last thing, Birdseye has fairly heavy caching built in. It stops people from hammering your website to try and create a denial of service. But I want to skip. I don't want to enable the cache for IXP Manager because IXP Manager also has its own caching built in. But I want what we do to be immediately reflected in IXP Manager by being logged in as a super user. So I'm just going to tell Birdseye via this file just to skip caching from my IXP Manager IP address. Again, straight out of the documentation. That should be it. For IPv6, I've done it for IPv4. I just have to copy that into IPv6. And I think that the only change I need to make for IPv6 I think that's it. Easy as that. Now that that's done and working, in my IXP Manager, and if you remember, when we configured our root servers, we did tell it where the API was. And I did tell you that this, on my demo system, resolves to this IP address. So all things being well, my looking glass should be working. And it is. So my looking glass is now talking to my IPv4 root server. I can see I've got 3 clients. I'm receiving 55 prefixes from HEAnet, 5 from SkyTel, 7 from Aptus, and this is the amount I'm exporting to each of those. So my looking glass is working. That is brilliant. What I want to show you is just on the looking glass. Let me switch to the IPv6 looking glass, and let me look at what we're advertising to Aptus. So we're advertising 4 prefixes to Aptus, 1 from SkyTel, 3 from HEAnet. I'm going to log into my HEAnet client where I'm running Bird version 1. And I'm going to, on my IPv6 config, I'm exporting these 3 routes, okay, via this protocol. Now, you don't need to understand any of this. What I just want to show you is if instead I changed my export rules to add a tag, what would happen? So I'm going to add this 103 community tag. So I'm going to do that. I'm going to reconfigure my Bird root server. Again, this is just a client. So before, I was just getting a single path. That tag, the 103, should prepend this 3 times for this member, and lo and behold, it does. On the IPv6 looking glass, that was for Aptus. For SkyTel, that's not the case because I specifically said in my community, only do that for AS 49567. So that's my community tags running. We may go over slightly here, but we've covered those 3 there really, really quickly. We're now going to look at IRRDB filtering. Very quickly, IRRDB filtering is used to ensure that the root server will only accept and then advertise routes that a particular network should be able to advertise. And by should, what I mean is there's no guarantees. Remember, you know, a LEAR, like many of you might be, register your routes with a routing registry, and that might be with APNIC or RIPE, but it might also be some commercial versions. And the quality of these vary greatly. I know RIPEs is very good. I presume APNIC is very good. Some of the commercial stuff can have a lot of dirty information in them. So it's kind of trivial for a malicious actor to be able to create a situation where they can advertise routes that they shouldn't be able to. But the main thing is that this stops people from accidentally doing bad things. IRRDB filtering has and still is, even with RPKI, it still is a standard. We'll talk about why that is important in a minute. This is an example of two IRR, Internet Routing Registry Database, IRRDB records. The main thing about an IRRDB record is it has a root or a prefix and an origin AS number. So what you're saying is that this prefix should come from a BGP path that has an origin AS of 65501. How this is the same as how most people do it these days. We've got a tool called BGP Q3. You can, here's so apt-get, so apt install. I already have it installed. So it's part of the Ubuntu distribution. BGP Q3, give it an AS number, and it will give you a bunch of prefixes for the root entries that are registered with the origin AS being AS2128. So these are just some examples of that. The J means JSON. So rather than giving it me in this sort of Cisco version, give me a JSON version. This is what IXP Manager does. We also have the concept of AS sets. And if we go back to IXP Manager, if we look at HEANet, when we added that member, we gave it a peering macro or an AS set. We said AS HEANet. If we looked at, for example, Aptus, that didn't have an AS set, it just has an AS number. So for Aptus, we only get the prefixes for the AS number. For HEANet, we get it for the AS set. An AS set is where HEANet create this IRRDB object called an AS set, gives it a name, and then it sets up all the AS numbers that it will advertise routes for. So routes that have an origin AS in this set will be allowed for HEANet. And this is kind of where the weakness is, because you can add pretty much any members you like to your own AS set. There isn't any particular check. The hope is in time that RPKI will have something that will secure this. There was an attempt called AS Cones, but that seems to have not gotten anywhere currently. IXP Manager will recursively unwrap AS sets. So you can see a HEANet's AS set contains an AS set of itself. It will unwrap and keep unwrapping until it gets all of the prefixes. So how does that work in IXP Manager? The database will be updated every 6 hours by the scheduler, which is something you set up when you install IXP Manager. And then the root service get updated whenever you run that Reconfigure All script. These things are transaction safe. So if both of these were running at the same time, there would be no ill effect, right? So they're fully atomic on the database end. So there's no issue with trying to coordinate these to not run at the same time. There's no problem there. You can also do it manually in the UI. So if we take a look at Aptus here, in the UI, I can view/update IRRDB entries. Now, I get an error. IRRDB only applies to customers who are root server clients, which are configured for IRRDB filtering. And that is absolutely spot on, because if you remember, when I set up Aptus's interface, I said that they were a root server client, but I didn't tick apply IRRDB filtering. I'm going to do that now. I'm going to do the same for HEANet. When you add members, by the way, oh, sorry, that was root server client to set up HEANet. Did I do that one already? I wonder. When you do this, right, it's done for both of them. It mustn't have been done for, sorry, I'm just going to check HEANet again. I didn't think I had it turned on. I didn't, sorry, my mistake. So when you, by default, it's turned on, by the way. I turned it off for this demonstration. You should never configure a client that doesn't have IRRDB filtering enabled. So I've turned it on for them. Now, if I go back to Aptus, because my scheduler hasn't ran, so my database, I presume, is empty. You can see it is. There's IRRDB prefixes for v4 and v6, and there's a set of IRRDB AS numbers. So the origin AS. If you remember, our IRRDB entry had a prefix and an AS number. So there's two sets of information we need to update. You can do that manually here. And there we go. I've now gone off and found 7 prefixes for this AS number. They've been added to the database. I can also, on the command line, I can run a command within my IXP Manager. I can tell it to update the prefix database, and I can tell it to update the ASM database. So we found ASs for Aptus, we found ASs for HEAnet. So that's all been updated now. And that was all, so manually via the UI or manually via the command line too. Before we ticked the apply or IRRDB filtering box, our configuration for the client was this ASN was configured not to use IRRDB filtering. So what has it changed now? Well, let's have a quick look at our routers and our config, and we'll just scroll down to root server clients. So here's HEAnet, and if you take a look, we now have quite a difference. Okay, with all of this stuff added in. What does all of that stuff mean? Well, we've got the set of AS numbers. So for HEAnet, there's a bunch of AS numbers. For Aptus that we're looking at here, there's just one AS number. We make sure that the origin AS, the last non-aggregated, is the origin AS is part of that set. If it's not, we're going to filter it because we don't know what that origin AS number is. We're still skipping RPKI. Now we have all of the networks that we've learned from IRRDB. And what we do is we check if the network is if it's not in that set, we are going to filter, prefix filtered. Otherwise, we're going to just put an informational tag. This has been checked by our IRRDB and it is valid. So we've added in that check. We've done our IRRDB filtering. What I want to show you is on my root server, I want to reconfigure because I've done the IRRDB, so I now need to tell the root server to use a new configuration. And now when I go into my looking glass, let's go into V4, let's go in for Aptus say. So I've got 7 prefixes. If I look at the detail of any of those prefixes, this is where my informational tags come into play. One info tag was IRRDB valid. We've checked it, it is valid, right? One is RPKI not checked, information. We haven't checked RPKI. Both of those things came straight out of info RPKI not checked and IRRDB valid, straight out of the configuration. Okay. The other thing to have a look at here is I'm just going to go into Aptus's own client configuration. I'm going to advertise 4 bad routes. So I'm just going to uncomment those lines. I'm going to reconfigure Aptus's client configuration. What does that now look like in here? I should be advertising 4 new routes. I am. But we've got these exclamation marks, and that means that they're being filtered. If we go and look at the detail, we can see that one has been filtered because it's clearly private IP addressing, so it's a Bogan, it's a Martian. We can see this one is /22. So this is IRRDB prefix filtered. This is not a prefix that Aptus owns. This root is registered for a different AS number and it has been filtered. This is a /32. That is way too long. We don't allow that. We only allow /24 or smaller. And this is just another random prefix, IRRDB prefix filtered. So you can see it's all working. And you can see we got the telemetry in the looking glass to show us. I'm very conscious that it's 3 minutes past the hour. I've got one last thing, RPKI, which is really important, and we'll have it done in 5 minutes. I'm just going to bang on and get that done because I think this would be we would be losing out if we didn't get the RPKI done. So RPKI. We saw earlier on that IRRDB was a prefix with an origin AS number. That's what we got out of the routing registry database. RPKI is a cryptographically secure replacement for that, and it adds one extra bit of information, maximum prefix length. So if the root was /16 in IRRDB and we got advertised as 2/17s. By default, IXP Manager wouldn't accept that. We would go and tell our member, go and create 2 root objects for your /17s. Create the root objects for what your routing policy is. With RPKI, they could go and say, look, it's a /16, but we'll allow up to a /17. Okay. An RPKI validator, or also known as relying party software. To rely is to depend on or to trust. So again, this is cryptographically secure. So it downloads and verifies the global RPKI data set, and then we can feed that into our root server and check the prefixes as they're advertised. There's a bunch of different software. They're all linked here, and you can get the slides afterwards. How do we do this with IXP Manager? Again, there's a wealth of documentation. Where's my documentation page? So features, RPKI, we have it here, tells you all about installing RPKI, and particularly it has instructions for 3 different validators. So you can go and look at exactly the instructions on how to install them. It's all fully covered in documentation. I am going to, in 2 seconds, I'm going to install rootnative. So on Ubuntu 2004, sorry, I'm going to do that on the root server. You have a choice. You can create dedicated RPKI servers, or what a lot of people will do.
Recording
so the first few
in progress.
checks are to try and guide the user to fix what we think is the actual problem before it ends up down here. And when we get down here, we check the origin AS is in a set of ASNs from the member. So we check the origin AS. Then we check RPKI. And if it's valid, we're finished. We're going to accept that prefix, Frank. We only do the IRRDB if it's unknown. And that's the right thing to do, because RPKI should be prioritized above IRRDB, because with RPKI, the user has gone to the effort of telling their rear to, to cryptographically sign this ROA, this root object authorization, to say that it should be valid and it should be accepted. So if the RPKI entry exists, we don't move on to what would be a much dirtier, less precise IRRDB entry. So the answer there is yes. Any chance that's finished? No. All right. Any other questions, or anyone else want to jump in? I'm also aware that I think Kenrick is running a survey as well. I think the link is in the chat. If people want to fill that out for APNIC, that would be very useful, I think.
Extremely useful. It helps guide what we deliver as content. Being able to get specialists like Barry in to talk about IXP Manager and others that we've had in this year thus far. So having your feedback on these webinars is extremely important to us. So please be honest with your feedback and let us know what you actually think.
And just for my own part, folks, I'm sorry the end of that was rushed when we got to the sort of real meat of IRRDB and RPKI. I had done a few practice sessions myself, and I was under the 2 hours. I think I just probably spent too much time on the intro stuff at the start. But again, this is recorded, so you can certainly watch it back a bit slower than I did.
The recording will be available in the Academy in about 3 or 4 days.
Right. I'm not seeing any other questions there, Frank, I think.
Oh, I think we're good.
All right, folks. Well, look, thanks a million for listening. I've just put a few links up there. The IXP Manager website really is the place to go and get all of those videos. The mailing list links are all there. The documentation, of course, is probably one of the most important places to go. And as well as the webinar that APNIC put up on this, I'll try and cut maybe 3 videos, tutorials myself to add to the IXP Manager website while I have this demo system set up. And I'll try and just go a bit slower into a bit more detail on the IRRDB and the RPKI stuff. My own Twitter handle and email address are there as well if you have any questions. So again, thanks very much for attending and listening. I hope it was useful.
Thank you very much, Barry. Lovely to have you.
Thank you, Barry. I will probably see you next time.
Brilliant. Thanks a million, Kenrick.
Thank you.